the test is on 19th June. So they're saying they everything they cover up to 19th June is the syllabus. So I'm not really sure.
Okay, what about you, Iram? What is the syllabus and the date of exam?
They have said that at the end of June they would conduct, but not yet. The syllabus is not given yet.
Okay. So basically, today is our first lecture of chemistry. So I'm going to give you, I will start from very basic. Okay, some basic concepts of chemistry. So basically, we are going to start from very basic, which is it is our fundamental to build your basic very strong. If the basic concept is not clear, it will be very difficult to crack any competitive exams. So some basic concepts of chemistry. We will start with the with matter. In class 9th, we have already a definition of matter. What is matter? So anything which occupy a space and have some mass. A space and have some mass is called matter. That means anything which occupy some space, that means it has some volume and have some mass, that anything it's called matter. Is that clear, everyone? Like can you call elephant and a matter?
Yes,
No.
sir.
Yes, elephant is a matter because it occupies space and have some mass. Human beings matter. Can anyone tell me air is a matter or not? Arnav and Iram.
So it is.
It is. A smell is matter or not? Iram.
No, sir.
Iram, I want answers from you.
Yes.
A smell is a matter or not?
Yes.
No, no, a smell is not a matter. Air is matter. A smell is not matter because it doesn't occupy any space and doesn't have mass. Does a smell have any mass? No, it doesn't have any mass. It is just sense. Okay. And next thing, heat. Heat is a matter or not, Iram?
Not a matter.
No. So basically, how we define matter? Anything which occupy a space and have some mass. Anything which have some volume and have some mass. We can also define like anything which have some volume and have mass is called matter. So matter is classified on two bases. The first one is physical classification. Physical classification. And the second one is chemical classification. Chemical classification. Physical classification is basically, it is about the physical state, you know already. Please write it, then I will change the slide and explain what is the physical classification and what is chemical classification. Please let me know if you are done with this.
Done, sir.
Okay. Iram, are you done? Okay. So see, what is the physical classification? Basically, we divide physical state like solid, and then liquid, and then gas. So how we define solid, liquid, and gas? how we define solid, liquid, and gas. Solid is basically fixed shape and volume. Fixed shape and volume. Liquid is defined by fixed volume but not fixed shape. I will give example of all of this. And what about gas? Neither fixed volume, neither fixed shape, nor fixed volume. So you can see that you cannot change the shape of solid until or unless you are going to apply some external force. And it has basically solid has fixed shape and volume. What about liquid? Liquid has fixed volume, but when it comes fixed wait a minute, I just wrote it wrong. Fixed volume but not fixed shape. So what I was saying is liquid has fixed volume but not fixed shape. If you are going to put water from bottle to a glass, initially it was in shape of bottle, and later on, after putting it, keeping it in glass, it will be the shape. It will be in the shape of glass. So liquid has fixed volume but not fixed shape. I again wrote it wrong. Fixed shape. So basically, liquid has not fixed shape, it has fixed volume. What about gas? Gas has neither fixed shape nor fixed volume. If you have a full tank of cylinder LPG, it will have volume equal to the cylinder, equal to the volume of cylinder, and it has a shape of cylinder. But when you are going to open it up in a room, it will have shape like the shape of room, and it will have volume equal to the volume of the room. So basically, gas has neither fixed shape and nor fixed volume. Liquid has fixed volume but not fixed shape. Solid has fixed shape and fixed volume. Is this clear? The 3 points?
Yes.
Yes.
Okay. One more important, the main factor to decide whether it is solid, liquid, or gas is intermolecular forces. Intermolecular forces. So basically, intermolecular forces of attraction. If between particles are very high, that particle will be solid, and if intermolecular forces between particles is moderate, that is liquid, and if intermolecular forces of attraction is very low, then that is basically gaseous. Okay, please write it, and then I will explain chemical classification. Please do it.
Done, sir.
Okay, now Arnav, very good. Iram, are you done with this?
Yes, sir.
Okay, going to explain chemical classification. So basically, when it comes to chemical classification, so basically chemical classification of matter. Matter is divided into two parts. The first one is mixture, and the second one is pure substances. Pure substances. Mixture is divided into two parts. You already know from class 9. That is homogeneous mixture, and second mixture is basically heterogeneous mixtures. Now again, if you are going to classify pure substances, it will be classified between three parts, that is elements. The second one is molecules, and then compound. This is the chemical classification of matter, mixture, pure substances. Mixture will have, there are two types of mixture, homogeneous, heterogeneous. Pure substances are of three types, elements, compounds, and molecules. Please write it, and then we are going to define from mixture to compound. Six for
Done, sir.
done on or no?
Yes, sir, done, sir.
Very good. So going to start next point, that is mixture. So what is mixture basically? See, I'm going to define it and then I will explain it. When two or more substances, when two or more substances are mixed in any ratio, mixed in any ratio, the ratio is not fixed. In compound, you will see the ratio is fixed for a part, for a specific compound or for a specific product, but in mixture there are differences. This difference is basically when two or more substances are mixed in any ratio, that mixture is that product will be basically mixture. It is of two types, homogeneous mixture and heterogeneous mixture. See what is the difference between homogeneous and heterogeneous mixture. Homogeneous mixture, we can define it. It is the mixture which is uniform throughout, which is uniform throughout the mixture is called homogeneous mixture, and the mixture which is non-uniform. Non-uniform, what does it mean? I will explain again. Non-uniform is called heterogeneous mixture, or we can also define it, a mixture which has phase equals to 1, which has phase equals to 1 is called homogeneous mixture, or a mixture which has phase greater than 1 is called heterogeneous mixture. Just listen to me carefully and then you will write. Phase, what does it mean? If you are going to add sugar in water, and you just stirred it very uh, slightly, you stirred it for a while, what will you see in a glass if you just mix sugar in sugar in water? What happens after some time? You cannot differentiate whether where is sugar and where is water. It will look like same. If you are going to add salt in water, you will see there is no change between the particles. You cannot differentiate physically where is sugar and where is salt and where is water. If you are going to add water in milk, you will see only one phase from top to bottom. That type of mixture is called homogeneous mixture. Are you getting my point? Iram and
Yes, yes, sir.
Iram.
So please could you explain it once more?
Okay, just see. If you are going to add some water in milk, will you can you differentiate whether where is milk and where is water after mixing water in milk? Iram?
No.
No, you will see that there is no difference. You can see from top to bottom in a glass, it will look like same, that we can call it phase 1. It has only phase 1 before mixing or after mixing. Is that clear? That type of mixture is called homogeneous. If you are adding some sugar in water and you just stirred it for a while, where it will be soluble, fully soluble in water. You cannot differentiate it whether where is sugar and where is water after some time. So it will look like same from top to bottom, that is phase equals to 1. Now come to this point, heterogeneous mixture. Phase greater than 1. Phase greater than 1. What does this mean? If you are going to add sand in water, what will you see? You will see that sand is just settled down in the bottom of glass or in the bottom of container. You can easily see it or not, Iram and Arnav?
Yes.
Yes.
You can easily see it that sand is settled down. You will see basically two phase. You can see there is a container. Wait a minute, where it is? There is a container adding before adding sand, but after adding sand, you can see the sand is like this and water is like this. So there is two phase, this one phase and this one phase. If you are going to add this is water basically. If you are going to add mustard oil or petrol, so petrol will be above or on the surface of water because it has lesser density than water. So you can easily see two layer in the solution. So it will have two phase. That means greater the phase greater than one. That is type of heterogeneous type of mixture. I think uh, you are clear in this. If you still have any doubt regarding homogeneous or heterogeneous mixture, please ask me. Any question?
No, sir.
No, sir.
Okay. Please write it and let me know if you are finished with this. Hmm.
Done, sir.
Very good. So this is the difference between homogeneous and heterogeneous, and this is mixture. Iram, are you done with this?
Yes, sir.
Okay. Moving to the next part, that is basically pure substance. So basically, what is pure substance? Pure substance are made up of one or single or one or more than one type of elements. You can see there was element. What is element? It is made up of atoms, pure atoms, or you can call it atoms, pure atoms. Like if you are going to take example, it will be the list of periodic table. You can see hydrogen, helium, lithium, etc. It's all basically elements. When it comes to molecule, when same element combine, see the difference between element. Element is basically single. It is made up of single atoms. Single atoms. You can call it single atoms. Hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen. The elements present on the periodic table are all elements or not? Iram and Arnav.
Yes, sir.
Always in class 10th, I think you have remembered 1 to 20 elements. Hydrogen, helium, lithium, up to calcium. Have you remembered or not?
Yes, sir.
Very good. So see, this is all elements, and when we talk about molecule, Iram, have you remembered it?
Yes, sir.
Okay. So say what is molecule? Basically, when same elements combine, I'm going to define it when two or more same elements combine, a molecule is formed. A molecule is formed. You have seen that N2, H2, O2. Have you seen it? F2, Cl2. These all are molecules. You will see. You will see P4, S8, O3. These are all also basically molecules. When same element combine, a molecule is formed. When different elements combine, a compound is formed. Are you getting my point?
Yes, sir.
See, what is compound? Iram, if you have any doubt, please ask me. What is compound? When different elements combine, compound is formed. Compound is formed. So basically, you can see H2O, CO2. You have seen the molecules like H2O, CO2 in class 10th. Also, CaCO3, calcium carbonate. Also, you have seen calcium oxide, CH4. These are all compound. When different elements combine, a compound is formed, and there is a condition for forming compound. Combining between, you can see that hydrogen and oxygen will combine to give water, but the combination of hydrogen and water is fixed. If this ratio will be changed between hydrogen and oxygen, the product will also be changed. But in mixture, in any ratio, you can mix it and it will be mixture. But for a specific compound, for the formation of a specific compound like water, the ratio between hydrogen and water by mass is fixed. If the ratio is disturbed, the product will also be changed. Are you getting my point, Iram? Arnav?
Yes, sir.
Okay. Arnav, you have studied the laws of chemical combination, basically law of multiple proportion, law of definite proportion.
Yes,
So in law of multiple proportion, what we study is if you are going to change the ratio, the product will also be changed.
yes, sir.
We will see it in next class or next class. Please write it.
Okay, sir.
Done, everyone.
1 minute, sir.
Okay, take your time and do it. Iram, have you studied this chapter before?
No, sir. In our school, they've started from a structure of atom.
Okay, no problem. Just don't leave it. Please try to study it with the lecture that I'm teaching you. And also read, if you have some time, please read NCRT, and I'll give you homework and assignment. You have to do it.
Done, sir.
Iram, are you also done?
Yes.
Okay. See, have you studied physics? the first chapter in class 11?
Yes, sir.
So you will study in unit and dimension, that is a SI unit, CGS unit.
Yes, sir.
Yes, so see, you will learn that SI unit of mass is what? Kilogram. And SI unit of length, that means distance, is meter. And SI unit of time, that is second. Also, if you are going for CGS units, mass is for gram. This is for cc for centimeter length, and s for second. This will be uh, coming in physics frequently, but this SI unit will be very helpful for us in chemistry. Okay. Now see, there are some terms which are very important in our chemistry: mass and weight. So see, what is the difference between mass and weight? In physics, we differentiate it. Mass and weight are different. That is fact. But in chemistry, when we talk about mass or weight, it will be same. But here I'm going to define the correct or correct definition of mass and weight. Mass is basically, it is a substance it is the substance wait a minute. Mass of a substance is the amount of matter present in it, that is called mass. And its SI unit is mass has a SI unit called kilogram. But when it comes to weight, it is force exerted by gravity. Weight is the force exerted by gravity on an object. So weight, since it is a type of weight is a force, so SI unit of weight is Newton, because weight is a type of force that is exerted exerted by gravity on an object. So this is the basic difference between mass and weight. But in chemistry, I will call I will tell you molar mass or molar weight. That will be same. Mass or weight will be treated as same. Is that clear, Iram? Arnav? But in physics, it will be different.
Yes, sir.
Yes, sir.
Okay. Please write it. Are you done? Wait a minute. Sorry. Yes.
Just a minute, sir.
Okay.
Done, sir.
Done, sir.
Wait a minute. Is your screen shared?
Yes, sir.
Sorry, it was disconnected. Are you done with this? Arnav? Arnav, are you done with this? Hiram?
Yes, sir.
Okay. So, Arnav, am I audible? We will talk about volume. What is volume basically? So I'm going to define it. It is the amount of space occupied by a substance. By a substance. So basically, there are a lot of units which we can write, but generally we will be asked to write the SI unit. So if you are going for SI unit of volume, that is meter cube, and other units are you can see centimeter cube or liter or milliliter or decimeter cube, whatever is can be the unit. You can see mass of unit of SI unit of mass is kg, but we also express in gram. So please write it. This is for volume. Then we will talk about temperature. So Arnav is disconnected, was disconnected. Arnav, am I audible?
Yes, sir. I
Okay.
got disconnected.
Yeah. Please write it.
So I'm done, sir.
Okay, the next one, volume. Are you done with the volume?
No, sir. Just give me minutes.
Okay.
Yes, sir. I'm done.
Okay. Now we will talk about density. So this very basic terms are very important for next chapters. Density, we already know what is what density is. Mass per unit volume. Mass per unit volume is called density. Is called density, and we can write density is equal to mass upon volume in mathematical equation. And you know that SI unit of density is, since we know that SI unit of mass is kg and volume is meter cube, so SI unit is basically kg per meter cube, and also other units are like gram per ml or centimeter cube, whatever is convenient, but this is the SI unit. Please write it.
Done, sir.
Done. Both of you done. Hiram.
Yes.
Now we will talk about temperature. So temperature is basically amount of hotness or coldness. So temperature, this has a SI unit. SI unit is Kelvin. SI unit is Kelvin. Other units are degree centigrade and Fahrenheit. And we have to know how to convert Kelvin into degree centigrade and Kelvin into Fahrenheit, or degree centigrade into Fahrenheit. Now see, Kelvin will be equal to degree centigrade plus 273. Whenever we need to convert degree centigrade into Kelvin, we just need to add 273. Exact value is 273.15. Wait a minute, Iram, you just joining. Arnav, are you there?
Yes, sir.
Now see, what I was telling you that SI unit of temperature is Kelvin. Other units are degree centigrade and Fahrenheit. And we have to know what is the conversion unit, how we will convert Kelvin into degree centigrade into Kelvin, Kelvin into Fahrenheit. So whenever degree centigrade will be converted into Kelvin, we just have to add 273 into degree centigrade and it will be converted into Kelvin. So in the same way, if we have to convert Kelvin into degree centigrade, we have to subtract 273 from the given Kelvin and we will get it into degree centigrade. Are you getting my point?
Yes, sir.
So if 0 degree centigrade have to convert into Kelvin, so Kelvin will have equal to 0 degree centigrade plus 273 and it will be converted into 273 Kelvin. If 100 degree centigrade have to change into Kelvin, Kelvin is equal to 100 plus 273, it will be equal to 373 Kelvin. And exact value of 273, basically it is 273.15, but for calculation part, we take it 273 Kelvin. So please write it, relation between Kelvin and degree centigrade.
Done, sir.
Are you done, or
Yes.
Iram? Okay. Now see the relation between, we have a formula in NCERT too. Basically, this is relation between degree centigrade and Fahrenheit. So what is the relation basically? There is a formula, degree Fahrenheit is equal to 9/5 degree centigrade plus 32. This is the formula. And if you have 0 degree centigrade and you have to change it in Fahrenheit, degree Fahrenheit will be equal to 9/5 into 0 degree centigrade, 0 plus 32. So degree Fahrenheit at 0 degree centigrade will be 32 degree Fahrenheit. Okay. You just have to put the formula, put the value in the formula and you will get your answer. Okay. And if there is a question to convert degree centigrade into Fahrenheit, Fahrenheit into degree centigrade, you just have to put the value here and you will get your answer. Are you getting my point? Iram and Arnav?
Yes, sir.
Iram?
Yes, sir.
Okay. Please, if you are done with this, let me know. I will give some questions and then we will move to next. Everyone done with this?
Yes, sir.
Arnav?
Yes, sir.
Okay. I'm going to give you question. regarding this. And there is no, I haven't written any direct relationship between Kelvin and degree Fahrenheit. And if you have Kelvin and you have to change in Fahrenheit, you just need to convert Kelvin into degree centigrade, and then you have to convert it into Fahrenheit. Are you getting my point? Convert
Yes, sir.
Kelvin into Fahrenheit, degree Fahrenheit. Like we have 298 Kelvin. 305 Kelvin. 373. Can you do this, or I should explain the first one?
So please explain the first one.
See, Kelvin into degree Fahrenheit, there is no direct relation I have written, but we know that Kelvin can be converted into degree centigrade, and degree centigrade can be easily converted into degree Fahrenheit. So for the conversion of degree centigrade, what I told you, whatever Kelvin is given, just convert it in minus 273 Kelvin, and you will get your answer into degree centigrade. If you have to convert degree centigrade into Kelvin, you have to add 273. And if you have to convert Kelvin into degree centigrade, you have to subtract 273 from the given Kelvin. Are you getting my point? Iram?
Yes, sir.
Arnav? Now see, if it is converted into degree centigrade, now it is very easy. We know our formula, degree Fahrenheit is equal to 9 by 5 degree centigrade plus 32. Now we just need to apply the formula and put the value. What is the value of degree centigrade? That is 25 plus 32. It will be converted, it will be cancelled. 5 5 ja 9 5 ja 45 plus 32. So it will be 7 and 5 437 degree Fahrenheit. Got it, Arnav and Iram?
Yes, sir.
Everyone done with this? Please do the remaining two questions.
So the second part is 89.6 degree Fahrenheit, and the third part is 212 degree Fahrenheit.
Okay, let me see. You can say how much degree centigrade in this?
Sir, 32.
32 degree centigrade, right?
Yes, sir.
Is there any answer from Iram?
Sir, just a minute, I'm doing.
Okay. The second part is basically 305 Kelvin. If you are going to convert it into degree centigrade, 305 minus 273, it will be 32 degree centigrade, right? So in degrees, degree
sir.
Fahrenheit, it will be 9 by 5 into 32 plus 32. So it will be, you can see 9 to the 18, 9 3 ja 288 by 5 plus 32. Have you solved it?
Yes, sir. 89.6 degree Fahrenheit.
Very good. So it will be 57.6 and plus 32, right? 89.6. Very good. And what about the second one?
This is the third one.
Yes,
Sir, it's 212 degree Fahrenheit.
very good. Any answer from you, Iram?
Yeah, sir, 212 degree.
Very good, very good. So this is the basic of some basic concepts of chemistry. After this, basically, there are laws of chemical combination. That is law of conservation of mass, law of definite proportion, law of multiple proportion, Avogadro, Gay-Lussac, and then we will come to the main chapter, that is atomic mass. So this is it for today, and I will be here in the next class soon. Okay, on Thursday, most probably. Okay.